Download this code from codegive.com, link in the description below. OK, let's dive deep into detecting closed sockets when you still have data buffered and haven't yet read everything. This is a common and tricky situation in network programming, especially in TCP, where connections can close unexpectedly. Understanding the problem. The fundamental challenge is that a TCP socket doesn't provide a guaranteed data available signal before the connection is terminated. You can have data sitting in the kernel's receive buffer and the other end can close the connection. Your read, or recv, calls might still return data for a while, but eventually, you need to figure out that the connection is actually gone to avoid infinite loops or resource leaks. Here's a breakdown of the common scenarios. 1. Normal shutdown, graceful close. The sending side calls shutdown, socket, shut_WR, or close, socket. The receiving side will eventually receive a zero-length read, EOF, end of file, after it has read any remaining data in the buffer. This is the cleanest scenario. 2. Abrupt connection reset, RST. The sending side might have crashed, or a firewall might have forcibly terminated the connection. The receiving side may receive an ICANN reset error on a read, or recv, call, or even a SIGPIPE signal if it tries to write to the closed socket. 3. Idle timeout *. A firewall or network device might terminate a connection that's been idle for a certain period. You might not get any explicit notification until you try to read or write. 4. Half-open connection *. One side of the connection is unaware that the other side has disconnected. This can lead to wasted resources and application errors. This is harder to detect. Key techniques and strategies. Here's a multi-pronged approach to robustly detect closed sockets when you have a buffer. 1. Non-blocking sockets with select, /pol, /epol, ***. The foundation for reliable detection is to use non-blocking sockets along with one of the I/O multiplexing mechanisms like select, pol, or epol. These allow you to monitor multiple file descriptors, sockets, for readability, writability, and errors without blocking. Why non-blocking is essential. If you use a blocking read, call on a socket that has no immediate data available, you'll block indefinitely even if the connection has been closed. Non-blocking lets you check for readability and errors before trying to read. How select, /pol, /epol, help ***. They tell you if a socket is ready to be read from without blocking. They also tell you if a socket has an exceptional condition, like an error or the other end closing the connection for writing. 2. Careful read, /recv, call handling ***. Always check the return value of read, or recv. 0, you received data. Process it and continue reading. 0, this indicates the other end has performed a graceful shutdown, closed for writing. No more data will be received. This is your EOF signal. 0, an error occurred. Check errno to see what happened. Errno == again, or ewould block, means try again later, because the socket is non-blocking. Errno == ICANN reset means the connection was reset. Errno == EPIP means you tried to write to a socket that's closed for writing. 3. Tracking bytes remaining ***. If your application protocol involves fixed length messages or messages with length headers, you'll need to keep track of how many bytes you expect to receive. This lets you distinguish between I've received some data but not the whole message yet and I've received all the data I'm going to get, and the connection is closed. 4. Timeout mechanisms ***. Even with select, /pol, /epol, you might still want to implement timeouts to handle situations where the other end has disappeared without sending a FIN, a signal indicating a graceful close. Asterisk set a timeout for how long you're willing to wait for data. If the timeout expires, consider the connection to be dead. 5. Keep alive probes, keep alive. Asterisk you can enable TCP keep alive probes on your sockets. The kernel will periodically send packets to the other end to check if the connection is still alive. If the other end doesn't respond after several probes, the kernel will close the connection, and you'll get an error when you try to read/write. Asterisk caution asterisk keep alive probes can consume bandwidth and might not be suitable for all applications. The default settings are often too aggressive, so adjust them carefully. 6. Application level heartbeats asterisk. Asterisk for long-lived connections, consider implementing application level heartbeats. Periodically send small ping messages and expect a pong response. If you don't receive a response within a certain time, consider the connection to be dead. This provides more reliable and application-aware detection of dead connections than TCP keep alive probes. Code example, using select, with non-blocking sockets. Explanation of the code. 1. Includes asterisk standard headers for sockets, I/O, error handling, and select. 2. Set non-blocking, asterisk sets the socket to non-blocking mode using FCNTL. This is crucial. 3. Socket creation and binding asterisk standard socket setup for a simple server. 4. Accept, asterisk accepts an incoming connection. 5. Setting the socket to non-blocking asterisk calls set non-blocking, to make the accepted socket non-blocking. 6. Main loop asterisk FD_0, and reads, asterisk clears the file descriptor set before each select, call. Asterisk FD_set, new socket, and reads, asterisk adds the socket to the read set, indicating we want to monitor it for readability. Asterisk timeout asterisk sets a timeout for select. If no activity occurs on the socket within the timeout period, select will return, allowing us to detect a potential dead connection. Asterisk select, asterisk the heart of the example. It waits for one of the following events. Asterisk the socket becomes readable, data is available. Asterisk an error condition occurs on the socket. Asterisk the timeout expires. Asterisk FD_ESET, new socket, and reads, asterisk checks if the socket is in the read set after select, returns. If it is, it means the socket is ready for reading. Asterisk recv, asterisk attempts to receive data from the socket. Asterisk bytes_received 0 asterisk data was received. Process it. Asterisk bytes_received == 0 asterisk graceful shutdown, EOF. The other end closed the connection. Asterisk bytes_received 0 asterisk an error occurred. Check error no. Asterisk egain or ewould block asterisk no data available right now. This is normal for non-blocking sockets. Just continue the loop and wait for select, to signal readability. Asterisk can reset asterisk connection reset by peer. Asterisk other errors asterisk handle other socket errors as appropriate. Asterisk timeout handling asterisk if select, returns 0, timeout, the code assumes the connection is dead. You could add more sophisticated logic here, like retrying a few times or logging a warning. 7. Cleanup asterisk closes the socket and server socket. Important considerations and enhancements. Asterisk poll, or epoll, asterisk for a large number of sockets, poll, or epoll, are generally more efficient than select. The basic principles of non-blocking I/O and error handling remain the same. Asterisk error handling asterisk the code example provides basic error handling. In a production application, you'll want to add more robust error logging, reporting, and recovery mechanisms. Application protocol. This example assumes a simple data stream. If your application protocol uses fixed length messages or length headers, you'll need to modify the recv and data processing logic accordingly. Buffering. The code uses a simple buffer to receive data. You might need to use a more sophisticated buffering strategy if you're dealing with large amounts of data or complex message formats. So_linger. Be careful with the so_linger socket option. Setting it to linger can cause close to block until all data has been sent, which might not be desirable. Consider carefully whether you need to linger and what the appropriate timeout value should be. Asynchronous I/O. AIO. For very high performance applications, consider using asynchronous I/O, AIO, mechanisms like AIO_read, and AIO_write. AIO allows you to initiate I/O operations without blocking and receive notifications when the operations complete. However, AIO can be more complex to program than select/poll/epoll. In summary, detecting closed sockets with non-empty buffers requires a combination of non-blocking sockets, careful error handling, and appropriate I/O multiplexing mechanisms. Choose the right approach based on the complexity of your application and performance requirements.